Okay, so this video I've got 4 examples that I think are a really good diverse mix of the different types of rules you'll need to use for taking derivatives. So let's just get right into it. I do have the answers down here because we want to make sure that our answer is correct. We also want to make sure that we're able to write our answer in a form that your professor wants you to, if it's homework that you're submitting, or if it's a multiple choice test, you want to make sure that your answer matches the correct form. It's one thing to get a correct answer, but if it doesn't look like any of the selections, then you're going to be stuck. So let's start with this one. Now, the first thing I'm going to do is I'm going to rewrite that square root as a 1/2 power. So of course, if you have a square root of something, it's the same as writing it to the 1/2 power. So that's what I'm going to do first of all. So I want to take the derivative of that. And then I'm going to apply the power rule with the chain rule, the extended power rule to this. So the derivative is going to be, the power comes out the front, and then the new power that's going to come out here, the new exponent, is going to be the original 1 minus 1. But we're not done. What you have to do next is multiply that by the derivative of everything that was inside the parentheses. So now this is going to be, and 1/2 minus 1 is minus 1/2. And then the derivative here, I'll just take term per term. So I'm going to have 4 times 3x squared, then minus 5. Okay, so now I'm going to, since that's a negative power, so this is a correct answer. There's nothing wrong with this, nothing wrong at all. But if the multiple choice selection, the correct one, looks like that, you're going to have to refine this. So we can't stop there. So I'm going to get rid of that negative exponent by now writing that as 1 over then the positive. And here, this is going to be 12x squared minus 5. Now, when you multiply two fractions, you just multiply the tops, numerator, times the bottom, denominator. So I'm going to have 1 over 2 times. And now, instead of the 1/2 power, I'm going to write that as a square root. And then the very last thing we do is when you have something that's not a fraction multiplied by a fraction, it gets multiplied in the numerator. So 1 times all of that, that's what my numerator will now become. Minus, and we see that now that matches. And that's where any professor would expect you to be able to get your final answer as. Okay? All right, so we'll go on. All right, let's look at this guy. Again, I'm not going to use the quotient rule, even though that's a quotient. So I'm going to do some rewriting. I mean, first of all, you can take that 3 out. I can further take it just out the front. And now, once again, I'm going to rewrite this as a negative exponent. So 1 over something to a power is the same as your argument to the negative power. So that's what I'm going to do, because I'm going to apply the power rule, the extended power rule. So the 3 out the front's coming along for the ride. And so now this negative 4 is going to come out the front. And then my new exponent here is going to be the old exponent minus 1. But I'm not done yet. I have to multiply it by the derivative of what was inside the parentheses. Okay. Now 3 times negative 4 is negative 12. And then, oops, my bad. No, we didn't have that. I just want the derivative of what's inside the parentheses. And now I want the derivative of this, and that's going to be 2 times 2x, which is 4x, and the derivative of 7 is 0. Now, this is a product. Negative 12 times 4x is minus 48x. And then the last thing I'm going to do is, I don't want any negative exponents in my final answer. That should have just been that. And so I'm going to have minus 48x times 1 over 2x squared plus 7. And then I'll multiply this by the fraction, so it just gets multiplied in the numerator. Okay, and then that's matching up. Okay. All right, onward to the next one. Okay, this one I am going to use the product rule and the chain rule combined. Okay, so I see a product here, and I'll call this one F, and I'll call this one G. So we'll start with the easy one. So the derivative of f is going to be 4x cubed. Now g is equal to this, and so the derivative of g is going to be 6 times 5x minus 1 to the power of 6 minus 1, which is 5, times the derivative of just what's inside the parentheses. Then the derivative of 5x is 5. And of course the derivative of minus 1 is 0. 6 times 5 is 30. Okay, so there's my g prime. Okay, now the derivative of this is, I'm going to use the I'm going to use the product rule. And according to the product rule, it's going to be f times g prime plus g times f prime. Okay, so let me make some. So I'm going to have f times g prime plus g times f prime of x. Okay, now again, this is a correct answer, but it won't look like that in the back of the book if that's a book problem, and if it's a multiple choice selection, the correct one won't look like that. What you have to do now is factor, and calculus students should remember how to factor. Okay, so we've got all right, so let's see what we've got in common. I might start with those. Now the most I have in common is 5x minus 1 to the 5th power. That's the most I have in common in both of those summands. So if I factor that out, what am I left with? Okay. So well, if you factor that out, what you need to ask yourself is, what is left when I divide each term by 5x minus 1 to the 5th? Okay, well, with that first term, that cancels out exactly, and I'm left with 30 times x to the fourth. Then I have a plus. Now, with this cancellation here, I'm going to have one of them left over in the numerator. So 5 of them will cancel out, and I'll have one left over in the numerator. Okay. All right. Now, it's still not looking like the answer, okay? So let me do some cleanup inside those big brackets. I'm going to need to multiply that, distribute that. So 30x to the fourth plus. Then I'm going to have 20, so 5x times 4x cubed is 20x to the fourth. Oh, sorry, 20x cubed. 5x times 4x cubed is 20x to the fourth. My bad. There we go. And then minus 4x cubed. Okay. $30x to the fourth plus 20x to the fourth is going to be 50x to the fourth. Then minus 4x cubed. Okay. We can still factor. These terms have stuff in common. So they have an x cubed at most in common with the letters. So I'm going to factor out an x cubed. What are you left with when you factor out an x cubed? Well, I'm going to have 50x and then minus 4. And then 50 and 4 have a 2 in common. Oops. So I can pull out a 2. And 50x divided by 2 is 25x. And minus 4 divided by 2 is minus 2. Okay, and x cubed times 2 is 2x cubed, so I'll put that out the front. And that does match. And so a lot of factoring involved. Factoring was about half that problem. If you're rusty on factoring, you need to get unrusty, get some more practice at it. Okay, and now let's go to the last one I've got for you. This one is going to use the quotient rule. So, and it'll be the chain rule as well. It's not going to be a straight. So I'm going to call that one F. And I'm going to call this one G. And let's get their separate derivatives like we did before. So the derivative of F, so I can do that term by term, 3 times 2x. And the derivative of minus 2 is 0. So that one was pretty straightforward. Okay, so this one, to take the derivative, I'm going to use the product rule, the generalized product rule, power rule, sorry. So this exponent comes out the front, and the new exponent is the old one minus 1, but we're not done. Then you have to take the derivative of what's inside the parentheses. So I'm going to have 3 times 5x plus 4 squared, then the derivative of 5x plus 4, which is just going to be 5. And then 3 times 5 is going to give me that 15 out the front. So that's my g prime. Okay. Now, the derivative using the quotient rule is going to be g times f prime minus f times g prime all over g of x squared. All right, so that's the quotient rule. Okay, so put it down here. G of x times f prime of x minus f of x, which is up here, times g prime of x. All over g of x squared. Okay, now that is strictly speaking a correct answer. However, as you can see, it doesn't look anything like what you would see in the back of the book or what you would see in a multiple choice selection. So I am going to need to make some room here. So we're just going to hope, fingers crossed, I didn't make a mistake in any of those derivatives. Okay. Well, first off, the denominator is, the rule says you multiply those exponents. So the denominator is going to be 5x plus 4 to the 6th. All right, now, what do the two in this difference have in common? Well, they have at most in common a 5x plus 4 squared. So I'm going to take that out. Okay. And then I'm going to be left with, once you remove a 5x plus 4 squared, this term is going to have one 5x plus 4 left over, then times 6x, then minus, and then this one's going to be completely gone. So I'll have that. Okay. Now, I have some cancellation because this is out the front. So two of these cancel. So that one will be gone, and I'll be left with that to the 4th power in the denominator. Okay. Now I'm going to go ahead and multiply everything through in the numerator. So I'm going to have 5x times 6x, that's 30x squared. Then I'm going to have 4 times 6x, that's plus 24x. Then I'm going to do the same to the next. Negative 15 times 3x squared is minus 45x squared. Okay. And then negative 15 times negative 2 is positive 30. Okay. Now, I do have some combining of terms. So 30x squared minus 45x squared is negative 15x squared. Then plus 24x plus 30. We're almost there. Always look to see if anything has a common factor, and 15, 24, and 30 have a common factor of 3. In fact, since the leading term there is a negative, I personally would factor out a -3. But I can see the answer there, they didn't do that. Okay, so I'll just factor out a 3. I'm just trying to get it to match the answer at this point. But you can see there's a lot of work to do that involves basic algebra, so not just calculus. So when you get here, this is the calculus answer, remembering the rule, getting those derivatives, but then the rest of this is just cleanup using algebra. Okay, so what's left inside those parentheses? Well, ask yourself, if you divide each term by 3, what would you be left with? And 15x squared divided by 3 is minus 5x squared. 24x divided by 3 is 8x. And 30 divided by 3 is 10. Okay, so after all of that, that's our answer there, which is matching that. Okay, now, personally, if it had been up to me, and you might see it this way in other books, I would have taken out a -3. Because books like to have the leading term being positive. And then what would be left in here is negative 15x squared divided by -3 is positive 5x squared. 24x divided by -3 is minus 8x. And 30 divided by -3 is -10. So this is also a correct answer. But I'm just looking at the form that I was given for the answer, and they wanted to do it that way. Okay, but you need to be familiar with how both of them look. Okay, so I am done. Woohoo! And I'm going to have another video on taking derivatives, but that one will have trig functions in there. Okay, so taking a little bit step up in the difficulty. All right, so I hope this helped you, and if it did, can you please hit that subscribe button and watch some of my other videos. Thanks a lot.